Hello friends, today we start with the new chapter in physics, ICSE standard 10, that is calorimetry. That is chapter number 11 of concise physics. Now the chapter calorimetry is divided into two parts. The first part is based on the heat capacity and the specific capacity of the substance, and the second part is based on the latent heat or the hidden heat of the substance. So these are the two parts. So in the first case, we are just going to see the change in temperature, and the second case we will be seeing the change in state of the body. So this is a very important chapter, considering the fact that it will be asked for at least for the 5 marks in the second section and plus 5 marks or maybe more in the first section. So around this small chapter has got around 10 marks of weightage in the examination. So right, quite a important kind of a chapter. It has got mainly what is the main thing over here will be the numericals. There is not much of the, I would say, the learning part over here. We don't have too much of the theoretical part in this case. Very few theory part over here, but mainly what is there are the numericals of this chapter, which are very important. So let's start with the chapter, that is calorimetry, heat capacity, specific capacity and its measurement. So before we start with this calorimetry, we need to understand what is calorimetry. The calorimetry is the measurement of heat. So we can easily consider that what is calorimetry. अगर कोई पूछे तो the simple thing is that it is the measurement of heat is called as calorimetry. Or so when we are talking about heat, we are talking about calorimetry. So when we are measuring the amount of heat present in a body, we are talking about calorimetry, because it is by the use of a device called calorimeter that we are able to measure the heat. So the principle of calorimetry and the calorimeter are the one which are going to be used for the measurement of heat. Now coming to the first part is about heat. So main thing is the concept of the heat. So the heat, we know very well, is a form of energy. Now why is it a form of energy? It's a simple reason that the heat is energy if it has got the capacity to do work, and the best example for heat doing work is the steam engine. So steam engine are the heat produced by the steam engine is going to run the turbine and or run the steam engine, or even the turbines and all are going to run by that. So accordingly we know that the heat is a form of energy, and that form of energy can be converted into another form of energy, and that's why the heat is a form of energy. Now if we tell that the heat is a form of energy, so what is exactly the heat? Will be the internal energy, internal kinetic energy, or any energy present in the internal molecules, or can say the particles of that particular substance, is called as the heat. So heat is the internal energy possessed by a substance. So that's the reason if we are heating that thing further, तो automatically the energy inside is going to increase, and अगर हम लोग ने उसको cool किया तो the energy inside is going to decrease. So that's the main thing about the heat. So let's see, we know that each substance is made up of molecules. The molecule in the substance are in the state of random motion, and each molecule exerts a force of attraction on the other molecules. Thus, molecules possess kinetic energy due to their random motion, and potential energy due to their random molecular attractive force. Okay, I just missed that particular line. So yeah, thus molecules possess kinetic energy due to the random motion, and potential energy due to the molecular attractive force. So the molecular attractive force between the two is giving rise to the potential energy, and the random motion of the molecules is giving rise to the kinetic energy of that particular substance. So The sum of the potential energy and the kinetic energy of the molecule is called the internal energy, and the total internal energy of all molecules of the substance is called its heat energy. So that's why we define heat as the total internal energy present in the molecules of the substance. So the total internal energy of the molecular substance is called as heat energy. A hot body has more internal energy than an identical cold body. When a hot body is kept in contact with a cold body, the cold body warms up while the hot body cools down. That is, the internal energy of the cold body increases while that of the hot body decreases. Thus, there is a flow of internal energy from a hot body to a cold body when they are kept in contact. The energy which flows from a hot body to cold body is called as the heat energy, or simply the heat. So we see that when two bodies, suppose I got these two bodies over here, one is at hotter and the other is cold, and if I bring them together, what is going to happen? It is going to happen that the hot body is going to transfer its heat from here to here, and the cold body. So accordingly, what will happen is after a few minutes, this will also this which was cold becomes warmer, and this which was hot is becoming cooler. So that's why they both are going to. There will be a transfer of heat taking place from a hot body to the cold body. So this transfer of energy, of heat energy from one body to another body due to the difference in the energy possessed in them is the heat energy or the heat. So when the two bodies are in contact with each other, there will be a transfer of the heat, that is a transfer of internal energy from a higher energy level to a lower energy level. So that's why we define heat as heat is the internal energy of the molecules constituting the body. It flows from a hot body to a cold body when kept in contact. So this will be the exact definition of the heat, that heat is the internal energy of the molecules of constituting the body, and it flows from a hot body to a cold body when they are kept in contact with each other. So like all other forms of energy, heat is also measurable quantity. The measurement of the quantity of heat is called as calorimetry. So this is the definition of calorimetry, that the measurement of the quantity of heat is called as calorimetry. So now we talk about the units of heat. So first of all, we define heat. So heat, we came to know, was nothing but the internal energy. Okay, and it is measured, the units of this are, of course, the first thing will be joule, because it is a form of energy, so it will be joule, but it is also measured in calorie. So calorie and joule both are the units of the heat. So joule, of course, because it is the standard unit of energy, of any energy, it can be measured in joule. And at the same time, because heat is a different form of energy and you can measure this different form in a different manner also, that's why you have this special unit for heat, that is calorie. So like all other forms of energy, the SI unit of heat is joule, symbol J. The most commonly used unit of heat is calorie, symbol KACAL. It is defined as follows. 1 calorie is the quantity of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. Now this is very, very, very important. What is 1 calorie? Now 1 calorie is going to be defined twice with some modifications. So initially, if we talk about 1 calorie, what is 1 calorie? If I have got 1 gram of water, and if this 1 gram of water, and if I'm increasing the temperature of 1 gram of water by 1 degree Celsius, then the amount of heat energy which is going to be required to increase 1 gram of water temperature by 1 degree Celsius is equal to 1 calorie. So we can define 1 calorie as 1 calorie is the amount of heat energy required to heat 1 gram of water by 1 degree Celsius. Okay, यानी अगर मेरे पास water है 1 gram and that 1 gram is at 24 degrees Celsius, if I am giving it heat and becomes 25 degrees Celsius, then the amount of heat which I have supplied to that water to change it from 24 degrees to 25 degrees is 1 calorie. Okay. In the above definition, it has been assumed that the heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius at each initial temperature is same. However, this is not true due to the non-uniform thermal expansion of water. Hence, the precise definition of calorie, which is also called as 15 degrees Celsius calorie, is given as follows. So, we presumed in the above definition that if I am increasing the temperature from 15 degrees to 16 degrees, then the amount of heat required is 1 calorie. Same way, if I am heating the water from 70 degree to 71 degrees, still the same amount of heat will be required. Or from 40 to 41, same amount of heat will be required. Or 49 to 50, same amount of heat will be required. 99 to 100, same amount of heat will be required. But this is not true. Okay, it is not true because it is found that the amount of heat energy required for 1 degree rise at different temperatures is different. So you cannot just standardize this thing कि अरे भले ना 70 to 71 है वो भी 1 कैलोरी है और 100 to 99 to 100 है वो भी 1 कैलोरी है और 5 to 6 है वो भी 1 कैलोरी है. No, it is not so. And that is the reason they have modified this particular definition, and they have converted into a form that not 1 degree change but specifically between 14.5 degrees to 15.5 degrees Celsius. So when the temperature of the water is converted from 14.5 degrees to 15.5 degrees, that is of course 1 degree change, but only between 14.5 and 15.5, only then that much amount of heat required is 1 calorie. Okay, so we are becoming very precise now. क्योंकि अगर 13.5 to 14.5 में भी वो 1 calorie नहीं होगा, it may be less than that or more than that. Similarly, 15.5 to 16.5 may not be the same, it will be different. Not only that, even 14 to 15 will be different. 14.5 and 15.5 is exact value is equal to 1 calorie. So we have defined this 1 calorie as, so what you will be writing in the examinations for the definition of 1 calorie will be this one, that 1 calorie is the heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. Okay, so 1 calorie is the amount of heat energy required to increase the temperature, or we can say raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. So the unit of calorie is related to SI unit as follows. So it is 1 calorie is equals to 4.186 joule. Okay, 1 calorie is equals to 4.186 joules, approximately equal to 4.2 joules. So that is approximation 4.2 joule, otherwise exact value is 4.186 joule. Sometimes calorie is a smaller unit of heat, so we take a bigger unit, kilocalorie. Okay, so 1000 calories. So quite simple that a bigger unit is used called kilocalorie, kcal, and where kilocalorie is 1000 calories is equal to 4200 joule. And we can define therefore 1 kilocalorie as the energy required to raise the temperature of 1 kilogram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. The unit kilocalorie is generally used for measuring the energy value of food. You must have seen that कोई भी पैकेट हम लोग खरीदते हैं या कोई भी maybe some sweets or anything, or even you take a packet of कुरकुरे वगैरह भी लेके तो भी उसमें लिखा रहता है कि एनर्जी इतना कैलोरी इतना, तो दो कैलोरी बर्निंग वगैरह जो लिखा रहता है that is nothing but kilocalorie. So kcal is what is written in the food packets about the energy possessed in the food in that particular thing. Okay. Now we see the concept of temperature. So temperature is just the measure of the hotness or coldness of the body. In fact, it is that particular physical quantity which will determine the flow of heat. Because we say that the heat is going to flow from a hot region to a cold region. So who is going to determine what is hot and what is cold? It is the temperature which determines that whether what is hot and what is cold. So that's why heat tha internal energy, whereas temperature is the quantity which is going to determine the flow of heat energy. So on keeping a hot body in contact with a cold body, heat flows from a hot body to the cold body, to which the hot body gets cooled while the cold body gets heated up or warmed up. So we very well know that when I take two bodies, hot and cold together, so definitely hot body cold body को गर्म करेगा और cold body अपने आप गर्म होगा and hot body will automatically get cooled. So this is how the flow of heat energy is going to be taking place from hot body to cold body. The body which imparts heat is said to be at higher temperature than the body which receives heat. Thus, temperature determines the direction of the flow of heat. So that's the main part, that the temperature is going to determine the direction of the flow of heat. When a body receives heat energy, the particles constituting the body starts vibrating more vigorously, so its temperature rises provided its physical state or dimensions remains unchanged. So in case of any particular substance, so if we have got a substance like this, so we know that this substance has got molecules in it. These molecules are at a random motion inside, and when I am going to start heating this thing, you will find that the random motion increases, so that's why the collision will increase, and accordingly the kinetic energy or the temperature is going to increase of this particular substance. So that's why unless and until there is any change in the state, okay, if there is any state change in state taking place, only then the temperature is not going to increase, but there will be only change in state taking place. But otherwise, if there is a heat given to a body, the heat given to the body causes the temperature of the body to rise because the internal energy of that body has increased. So the body which imparts heat is said to be at high temperature, and temperature determines the direction of flow of heat. When a body receives heat energy, the particles constituting the body starts vibrating more vigorously, and so its temperature rises provided its physical state and dimensions remain unchanged. Thus, temperature is defined as temperature is a parameter which tells the thermal state of the body. Okay, it's a parameter which tells the thermal state of the body. What do you mean by thermal state of the body? Degree of hotness or coldness of the body. So that's why we are mentioning in the definition itself that thermal state of the body, that is the degree of hotness or coldness of the body. It determines the direction of the flow of heat when two bodies are at different temperatures are placed in contact. So when two bodies of different temperature are placed in contact, then the direction of the flow of heat energy from a hot body to cold body is going to be determined by the term temperature. So the temperature, that's why we are defining temperature as temperature is the physical parameter which tells the thermal state of the body, that is the degree of hotness or the coldness of the body. It determines the direction of flow of heat when two bodies are at different temperatures are placed in contact. If there is no transfer of heat between the two bodies placed in contact, they are said to be at same temperature. So if I am taking two bodies and I see that there is no transfer of heat taking place from year to year or year to year, it means that both of them are at the same temperature. So if the bodies are at the same temperature, then they will not be having any kind of change of heat energy from one place to another place. But it doesn't mean that they are an equal amount of heat in them. In fact, temperature alone does not tell us the quantity of heat energy contained in the body. Experiment can find that the quantity of heat contained in the body does not depend only on its temperature. On imparting the same quantity of heat energy to different bodies, the rise in temperature is different for different bodies. The amount of energy contained in the body depends on the mass, temperature and material of the body. So it is seen that if I say that okay, ये दो body है, both are different material altogether, but the temperature of both of them are same, it doesn't mean that the amount of heat energy present in them are also same. The amount of heat energy present in both of them can be different, but still both of them can be at the same temperature. Or other way around, it is possible that both of them may have the same amount of heat energy, but one will be hotter, other will be cold. We can take a very simple example for this thing. Like for example, suppose you take two chairs. One chair is made up of iron and other one is made up of wood. और ये दोनों चेयर को हम लोग ने ओपन समर में ओपन में रख दिया जहाँ पे सन डायरेक्टली उसके ऊपर आता है. Now because the sun is falling on both the chairs, exactly identical chairs. That's why the surface area, contact वगैरह वो जो सब समझ लो सेम ही है, सब कुछ सेम ही है. Okay. Only thing is one is made up of wood, another is made up of iron. It is seen that after suppose like 2 hours of keeping it in the sun, it will be not possible for you to sit on the iron chair, but you could easily sit on the wooden chair. Why? Because the temperature of the iron chair would have been very high कि बैठोगे तो चटका लगेगा, whereas the wood जो है उसके ऊपर हम लोग आराम से बैठ पाएंगे. Whereas both of them were given the same amount of heat energy because the sun rays were exactly on it properly. There was no kind of none of a shadow on the wooden part and ऐसा कुछ भी नहीं था. Both of them had got the same amount of heat energy, but still the energy, so both the substances had got the same energy, but one the temperature did not rise, whereas the other one the temperature rise. So there the rise in the temperature in the iron one is going to be there, whereas wood में नहीं होगा. So you can understand that the heat energy is not dependent only on the temperature, it is dependent on many other factors also. The factors which are there, will be learning nothing, will be the mass of the material, mass of the substance, the temperature change, as well as the type of the material, okay, whether it's a good conductor or a bad conductor. So इस तरह से you can find that heat energy you cannot determine the amount of heat energy from the temperature. It is possible that a particular body which is at a lower temperature may have got a higher amount of heat in it, whereas the body which has got a higher temperature has got lower amount of heat in it. Because, like for example, if I am taking water, now water takes a long time to get heated up. और वही चीज अगर मैंने वाटर के बदले एक जगह पे मैंने कोई सपोज आई हैव टेकन सम पेट्रोल और समथिंग, इट विल गेट हीटेड अप जस्ट बाय अ सिंपल स्पार्क. Okay, so definitely what has happened, the amount of heat energy present in water is very high, but the temperature is low. But the amount of heat energy present in the petrol is very low, but the temperature is very high. So that's why the temperature only tells you the transfer of heat कैसे होगा. Okay, transfer of heat, the direction of the flow of heat is known, but it does not tell you that which has got more amount of heat and which has got less amount of heat. Okay. So that's why we will read this again, that experiment we can find that the quantity of heat contained in the body does not depend on its temperature. On imparting the same quantity of heat energy to different bodies, the rise in temperature is different for different bodies. That is precisely what I told you about the chairs. The steel chair will be, or iron chair will be more hot, more temperature will be there on the iron chair, whereas the wooden chair would not have that much amount of temperature. So the amount of heat energy contained in the body depends on the mass, temperature and the material of the body. Units of temperature, the SI unit of temperature is Kelvin, and the other most common unit of temperature is the degree Celsius. They are related as T Kelvin is equals to 273 plus T degree Celsius. Or more precisely, Tk is equal to 273.15 plus T degree Celsius. 2.15 का जरूरत नहीं है, but anyways. Thus, by adding 273 or 273.15 to the temperature in degree Celsius, we get the temperature in Kelvin. The zero of the Kelvin scale, called as the absolute zero, is the temperature at which the molecular motion ceases, it equal to minus 273 degrees Celsius or minus 273.15 degrees Celsius. No negative temperature is possible in Kelvin scale. Thus, a degree or temperature difference is same for both the Celsius and Kelvin scale. So it is seen that if I say that the temperature rise from 15 degrees to 16 degrees Celsius, there will be a equivalent rise in the Kelvin also. So यहाँ पे 1 degree rise will be a 1 degree rise or 1 Kelvin rise the same way. So of course the values will be different, but what is the, if I say what is the change in the temperature when the temperature is rising from 273 Kelvin to 274 Kelvin, and similarly over here 0 degree Celsius to 1 degree Celsius, तो दोनों में आंसर 1 calorie या 1 Kelvin or 1 degree Celsius ही होगा. So that is that both of them, the degrees, 1 degree over here is the same. Only thing is the initial point and the end point are different, but the scale wise, the division wise, they are same. We now come to the factors which are affecting the quantity of heat energy. So that's a very important part. That is going to be defining, or you can say deriving the uh, equation, or we can say the formula for heat. So the quantity of heat energy absorbed to increase the temperature of the body depends on three factors. First, mass of the body. So first thing is, we will say Q is equals to, is proportional to the mass. So we say that it is proportional to the mass. Okay. So let's see this thing. Object with different masses made of same substance absorb different amount of heat energy to raise the temperature by the same amount. For example, to rise the temperature of 1 kg of water by 1 degree Celsius, the heat absorbed is 1 kilocalorie. By the rise in temperature of 2 kilograms of water by 1 degree Celsius is 2 kilocalories. Thus, the amount of heat energy absorbed is directly proportional to the mass of the object. Very simple. If I taken 1 kg of water and I am heating it by 1 degree Celsius, suppose I require 1 kilocalorie of amount of heat. वही चीज 1 kg के पहले अगर मैंने 2 kg लिए तो क्या होगा? Automatically I will require 2 kilocalorie of heat. So that means that if I am increasing the quantity, if I am increasing the mass, automatically there will be respective increase in the heat energy required. So that's why quantity of heat required will be directly proportional to the mass. Okay. Second is, object with equal masses made of different substances absorb different amount of heat energy to raise their temperature by different amounts. For example, to raise the temperature of 1 kg of water by 1 degree Celsius, heat energy absorbed is 1 kilocalorie, while to raise the same temperature of same mass of water by 2 degrees Celsius, heat energy required will be 2 kilocalories. Thus, the amount of heat energy absorbed is directly proportional to the rise in the temperature. That's why we see that Q, that is heat, is directly proportional to delta T. What is delta T? Change in temperature. So, if the change in temperature is more, the heat energy required is more. If the change in temperature is less, the heat energy required is less. So, if I am going to heat something by 1 degree Celsius, then the amount of heat energy required is suppose 1 kilocalorie. The same thing if I'm heating it to 2 degrees Celsius, then the amount of heat energy required will be 2 kilocalories. अगर मेरे को 5 kg को करना है, 5 degree Celsius तक करना है, it will become 5 kilocalories. So more the difference in the temperature I require, more will be the quantity of heat required. So the temperature will be directly, the change in temperature is directly proportional to the amount of heat required. And finally is the object of same masses but made of different substances absorb different amounts of heat energy to raise the temperature by the same amount. For example, equal volume, equal mass of water and copper are heated through 1 degree Celsius. The amount of heat absorbed by water is nearly 10 times the amount of heat absorbed by copper. Thus, the amount of heat energy absorbed depends on the substance of the object, which is expressed in the term as specific heat capacity. So that is correct. Q is proportional to the specific heat capacity C of the object. That means that if I am heating two different substances, then the amount of heat energy required will be different in both the substances, even if the quantity, that is mass, or the change in temperature is the same. So it is not going to happen that if I got, like say I have got two containers, one containing water and other containing some petrol. So ये दोनों को अगर मुझे heat करना रहेगा, same quantity 1 kg over here, 1 liter over here, 1 liter here. This also I want to increase the temperature from let's say 24 to 30, and this also from 24 to 30. What will happen? This one will get faster, so that's why the petrol is going to take lesser amount of heat, whereas the water is going to take more amount of heat. This is because it is the inherent property of the material to absorb more amount of heat to raise its temperature by 1 degree Celsius. So that particular inherent property of the material is called as C, which is called as specific heat capacity. So depending upon the specific heat capacity of the substance, the amount of heat required will be more or less. If the specific heat capacity is more, the heat required is more. If the specific heat capacity of the substance is less, the heat required will be less. So it will be seen that the amount of heat energy absorbed depends on the substance of the object, which is expressed in the terms as specific heat capacity. So from these three we can understand that Q okay, is equal to, we'll direct right over here. It is because all of these are directly proportional, so it is mc delta t. So this is the equation over here. The constants are removed because the constant ka value is 1. That's why we are not taking that thing. So where, or else we can say C, it becomes a constant because this is dependent on the material. So here we can say Q is equal to M into delta T, but C is a constant which will be different for different materials. So the constant which we are using over here will be depending upon the material, which is nothing but the C. Hence we see that Q is equals to C M delta T or MC delta T, where C is the constant of proportionality, which is called the specific heat capacity of the substance. It is the characteristics of the substance and it is different for different substances. This gives us the differentiation between heat and temperature. So heat is a form of internal energy obtained due to the random motion and attractive force of the molecules in the substance, whereas temperature is the quantity which determines the direction of the flow of heat on keeping the two bodies at different temperature in contact. Heat, the SI unit is Joule, whereas temperature, the SI unit of temperature is Kelvin. Heat is the amount of heat contained in the body depends on its mass, temperature and the substance of the body, whereas temperature of the body depends on the average kinetic energy of its molecules due to its random motion. Heat is measured by the principle of calorimetry, temperature is measured by thermometer. Two bodies having same quantity of heat may differ in their temperature. Two bodies who have got the same amount of heat in them may differ in temperature, right? They may have got like I told you about the chairs, the iron chair and the wooden chair. Whereas two bodies of the same temperature may differ in the quantity of heat contained in them. Okay, so दोनों same temperature पे पर एक के अंदर more, like I told you about the water and petrol. So both had got the same amount of heat, but one was at a different temperatures. Or they could be at the same temperature, but could have been having more amount of energy or less amount of energy in them. Lastly, when two bodies are placed in contact, the total amount of heat energy is equal to the sum of the heat of individual body. So we can say that heat energy is an additive quantity. So if I say that this has got 20 calorie of heat and this has got 120 calorie of heat, I can say when I combine them together, it is 40 calorie of heat. Okay. But if I say in temperature this is 20 degrees Celsius and this is 20 degrees Celsius, it is not going to happen that this two will become 40 degrees Celsius. No. This will be, suppose this 20 and this 30, and if I combine them, then the total value of the temperature will be in between the two. It will be in between the 20 or 30 के बीच में 25 रहेगा. But it cannot be addition of the two. So that's why it is given over here that when two bodies are placed in contact, the total amount of heat energy is equal to the sum of the heat of the individual energy. So it is equal to sum. The heat is the sum of the energy. Whereas when two bodies of different temperature are placed in contact, the resultant temperature is a temperature in between the two temperatures. Okay, the resultant is in between the two temperatures. So this was about the differentiation between heat and temperature. We continue with the thermal capacity or heat capacity in the next video.